In 2009, three engineers at one of the biggest tech companies in the world asked a simple question: why is software development still so slow? Compilers were slow, dependency was messy, concurrencies were complicated, so they decided to build a new language, simple, fast, and modern. This is the story of Go, also known as Golang. From a small internal experiment at Google to powering cloud infrastructure, Docker containers, and modern thereof. This is the story of Go. In the early 2000s, software engineering faced a growing crisis. Large-scale systems was becoming more complex, servers were scaling horizontally, multi-core processors were becoming standard. But the two versions keeping up. Languages like C++, Java, and Python each had strengths but also pain points. C++ was powerful but complicated. Java was structured but verbose. Python was simple but slower and limited by the GILs for concurrency. Meanwhile, at Google, engineers was building massive distributed systems. Compilation time was long, build system was complex, concurrency was difficult. Something had to change. In 2007, three visionary engineers began designing a new language at Google: Robert Griesemer, Rob Pike, and Ken Thompson. Yes, that Ken Thompson, the co-creators of Unix, the co-creators of C. If anyone understands system programming, it was him. The goal was bold: combine the speed of C++ with the simplicity of Python and built-in concurrency for modern hardware. After 2 years of internal developments, in November 2009, Go was announced publicly. Go wasn't designed to be flashy, it was designed to be practical. Its core principles, such as simplicity over complexity, readable over cleverness, fast compilations, and built-in concurrencies. Go intentionally removes features found in other languages. No inheritance, no generics, no exceptions, no complexity type hierarchies. Why? Because complexity slows teams down. Go code is meant to be easy to read, easy to maintain, and easy to deploy. One binaries, no runtime dependency, just build and ship. That simplicity becomes Go's superpowers. Modern computers aren't just faster, there's multi-cores. Go's embrace this with two major features: goroutines and channel. Instead of complexity straight, Go can launch a live goroutine with a single keyword Go. Behind the scene, Go handle schedulings. This idea was inspired by communicating sequential processes and influenced by system work from Unix research. Concurrencies become simple, safe, and elegant. From backends and cloud systems, this was revolutionary. In 2013, a tool changed the infrastructure world: Docker. Docker was written in Go. Why? Because Go produces small, fast, static binaries, perfect for container, zone object arms, Kubernetes, also written in Go. Suddenly, the entire cloud-native ecosystem was powered by Go. DevOps engineers embraced it, startups embraced it, cloud providers embraced it. Go wasn't just another language anymore. It became the backbone of modern infrastructure. Major companies began using Go in production, such as Google, Uber, Tweet, and Dropbox. It's become popular for microservices, APIs, networking tools, cloud infrastructures, and CLI tools. Go's programs start fast, use memory efficiently, scale across CPU effortlessly. For back-end engineering, it hit a sweet spot. For years, Go refused to add generic. The creators believed generic would complicate the language, but the community debated constantly. Finally, in 2022, Go 1.18 introduced generic. It was one of the biggest updates in Go history. The language evolved without boundaries. It philosophy, simple first, power when necessary. How does Go compare? Whereas Rust offers memory safety and zero-cost abstraction, but has a steep learning curve. Whereas Python is flexible and great for scripting, but slower for high concurrency servers. Whereas Java is enterprise heavy, but Go compile faster and deploy simpler. Go sits in a unique position, not too complex, not too minimal, and balanced. Go continues to grow. The cloud isn't striking, microservices aren't disappearing, container aren't going away. Go remains deeply connected to native deployments, DevOps toolings, and distributed systems. With backing from Google and a massive open source community, Go future looks stable and focused.